Hey guys, welcome to MT Stack and you are watching LeetCode series of problem solving using Java, and today we are going to look at valid anagram. To solve this question, it is good to have knowledge on arrays, hash table and sorting. The difficulty level is easy and this question was asked in interviews for companies like Google, Facebook, Apple, Amazon, Goldman Sachs, etc. Okay, let's jump into the question. We are given two strings S and T and we need to check if they are anagrams or not. Anagrams basically means if by rearranging letters of first word we can get the second word. So if the two strings are anagrams, we return true, else false. Let's take a look at a few examples. Say our first word is peach and second cheap, so it is an anagram and we return true. Same way, if we have state and taste, again they are anagrams as well, so we return true. But if we have right and fight, these are not anagrams, so we return false. Let's try to form an approach. What if we sort both of these words alphabetically? So if we take same example, peach and cheap, so after sorting, we would get something like A, C, E, H and P for both of them. Now we can simply compare them, and if they are same, we can return true, else we return false. Let's look at algorithm for this. We start by sorting both of the strings and assign them back to the original variable. Now we compare these variables using equals method. If same, we return true, else we return false. So the approach is simple. Let's look at the time complexity. We know the worst case time complexity for any sorting algorithm would be O of n log n, so overall complexity will be the same. Let's try to improve this. Let's take the other example, state and taste. What if we utilize extra space in form of hash map or hash table? Here we keep letters as the key and the count of their occurrences as value. So if we start with the first string, we store count of each letter. We'll have S equal to 1, T will be 2, as there are two T's, A equal to 1 and E equal to 1. Now how can we use this info? What if we take this hash map and compare the count with the second string? One way could be we build another hash map for second string and then compare both hash maps. If all values in both of these hash maps are same, we return true, else we return false. Or a better way could be we simply take the same hash map and this time we try reducing the count of letters instead of increasing them. If they are anagrams, we would get all zeros for all the keys in the hash map. Let's try to do this for this example. So we start iterating over the second string and we reduce the count of each letter this time. As count of each letters are exactly same as the first string, by end of the loop we would have 0 in all cases. Finally, we can traverse over the hash map and see if we have all zeros. If so, we return true, else we return false. Let's look at the algorithm. We start by defining the hash map and we iterate over the first input string. We keep count equal to 1 and we input each letter as key and count as value into the hash map. But if certain character was already inserted in the hash map, like in this example we have T twice, we need to check if the character was already present in the hash map. If it was, we get the current count of this character from the map and we increase its value by 1 and we again put it back in the map. Now something similar for second input string, we iterate over the string. For each letter we get the count stored in the map, we decrease it by 1 and we store it back into the map. Fair enough? But what if there is any other letter present in the second string but was not present in the first string? That itself means both strings are not anagrams and we can simply return false. So we add a condition. If map.getC gives you a null value, that means this character was not present in the first string, so we simply return false. Now finally we iterate over the hash map to check if all values in it are zeros. If we find any non-zero value, we return false, else we return true. If we talk about time complexity, it is reduced to On because there are no nested loops and storing or reading from a hash map can be done in constant time. But wait, let's see if there is anything else in this logic that can be improved. We know that hash map is a derived or a library data structure. It uses concept of hashing to store the keys. But in this example, do we really need to use it? Or we can solve the same problem using any primitive data type like arrays. And remember, if certain problem can be solved with an array, it will always be a little faster than the hash map. But there is one problem. Here we need keys and values for our solution, but arrays doesn't have keys, they have indexes. So what if we use indexes as the keys, where A would represent 0th index, B would represent the first index and so on. So for this example, if we write this hash map, we would have something like this, and we can also see the size of the array will always be 26. So reading from this array will be considered done in constant time. But there is still one problem. How do we map letter A to index 0 and so on? By default, every character is mapped to their ASCII value. For instance, if we have a variable xyz of char data type and we write letter xyz, it would basically point to ASCII value of this letter. So letter A would point to 97th index, Z to 122nd index, and so on. Now to use index from 0 to 25 instead of 97 to 122, we can subtract 97 or simply character A from our variable. Using all these info, let's try to build an algorithm. Like in previous approach, we first define the map. Here we define this integer array of size 26. Then we iterate over the first string. And for each character, we increase the count of letters C minus A by 1. As discussed, we subtracted A to fix the ASCII value to point to the range of 0 to 25. Same way, we iterate for second string, but this time we decrease the count by 1 for every character. Finally, we check the letters array for any non-zero value and accordingly we return true or false. Time complexity for this solution would be O(n) and space complexity will be O(1) as the extra space of integer array will always be constant of size 26 irrespective of length of input string. Let's look at the Java solution. We start by declaring the letters array of type integer and size 26. Then we iterate over the first string, define char C over S. We increase the count of char C in letters array by 1. But remember, we need to fix the ASCII value, so we subtract char A from variable C. Same way we do for second input string T, but this time we decrease the count by 1 using minus minus. Finally, we iterate over the letters array. Anywhere if letter L is not equal to 0, they can simply return false. Finally, we return true. Let's add some edge cases. We know that if the length of two input strings are not same, they cannot be anagram. So we can return false immediately from here. This should suffice. Let's run this. Perfect. See you guys in the next one.